Good afternoon, good evening, everybody. I hope you're enjoying the QA Day 2021, QAZ Day 2021. So we have a great session lined up for you. We've got panelists, our experts from our practice, Artem Rosmenko, Andrei Varabiu, and Srikant Mohan to discuss about cloud native testing. Cloud native testing these days are the buzzword in all of our engagements that we see come across due to various trends in the industry. And so we're going to be spending the next hour or so talking about some of those strategies, testing challenges, imperatives, and so on. As audience, we like you to participate actively, ask our panelists, our experts questions. I hope you can use the chat window on the community page so that we can post those questions to our experts and get you the answers. All right, so let's get a start with a brief introduction and an opening statement. So maybe I'll open the floor with all of you, and maybe we'll start with Artem, and then we'll go around. And maybe from your perspective, Artem, you could start with describing from your perspective what cloud native applications definition might be, and then we'll go from there.
Okay, yeah. So hi everyone, right? And as Vincent mentioned, right, the cloud native are more like a buzzword now, but apart from that, that's a real thing, right? So everything which utilized sort of cloud native technologies born in the cloud is the cloud native app, right? So like once we're speaking about all of this function as a service, right, all of this containers, orchestrated Kubernetes, SaaS databases, and all of that, it's all about cloud native, right? And apart from that, there is a line which divides, right, the cloud native versus the migrated applications which heavily rely on virtualized services, which basically uses some lift and shift approaches for migration and stuff like that. So there is a bit of a difference in how we test one over another.
Great, thank you, Artem, for that opening statement. Over to you, Andrei. From your perspective, do you want to add anything to that perspective that Artem shared?
Oh, not that much to add, except the thing that all these distributed architectures bring a lot of additional complexity to the testing, right? And now we need not only to test the functionality itself of the applications, but a lot of additional things such as reliability, such as possibility to scale, and so on and so on. And that's probably is going to be one of the most important and major topics of today's conversation.
Great, Andrei. Indeed, we'll be getting to some of those things you rightly highlighted. Srikant, from your perspective, any opening remarks with regard to cloud native applications, any experiences you'd like to share?
Yeah, thanks everyone. Thanks, Venkat, for the intro. The cloud native applications are more towards how, it's not where we are building them. It's more towards how we are building them. So as Artem and Andreas called out, there are complexities are being added as when we come on to cloud native. It means like, it's a distributed architecture. Distributed architecture is a large area, right? Now, the most of the times we work on multi-cloud environments. It might be Google and AWS coming together for a solution. The same thing is with hybrid cloud scenarios where we have local on-premise versions which interacts with the public cloud, and and the entire cloud native application developments comes with the microservices. So that's again, it gives you an overall complexities on how do you trace and isolate problems as well. Yes, during this session might be we will be more speaking about the details and the problems. So this is my view about how we about cloud native application, Venkat.
Yeah, interesting, right? So it's also so nebulous, but at the same time, there's so many moving parts, as Andre mentioned, and Artem also highlighted. The subtle but important difference between lift and shift and born native, cloud native development, right? Increasingly, we are seeing born digital companies using the cloud as a platform for development and deployment itself, and that requires a different orientation from application quality perspective. So maybe you could throw some light, from that point of view. Srikant, maybe you can start by talking about how the test vector and the quality strategy should be different when it comes to the cloud native applications that leverage those distributed services for horizontal scaling and so many other benefits that they provide.
So see, the major thing when we speak about cloud as is, right, when during any of the digital transformation projects, what we are getting, it's just not one silo set of programs, right? So there are SaaS, PaaS components which comes in line when we are building all these products, right? So when we speak about SaaS, something like ServiceNow, which do the ticketing, might be Salesforce, getting a CRM and sales data, and you also have your integration layer built on AWS on any of the clouds, right? Between the Kubernetes and stuff. So one of the silent thing which we need to worry about is on scalability, reliability, availability, and on the performance of the system, along with the functionality aspects. All these tool sets or the layers are integrated using endpoints. So now the total thing will move on to integration testing, where the much more focus will be on the integration testing and in the lower level of testing, like in the unit and the integration testing make a prominence than in the UI layer when we are taking on cloud native applications.
Sure, indeed. So, Henry, so we talk about the idea of monolith to microservices as one of the paradigm shifts as we see increasing adoption of cloud native applications. And that brings in complexity, inherent complexity. And as a tester and from a perspective of assuring those services, what has been your experience working with our clients in that regard?
Well, probably this interesting thing I would like to share in terms of the complexity and testing parameters that as applications become smaller as microservices, right? When we move from monolith towards the microservices, a lot of integration testing comes to the picture, as we discussed, right? Now, the problem is, how do we test those integrations? Do we need to introduce some mocks or steps or stuffs, right? Or do we need to test it with real instances of services? And how do we split the work between the functional testing or test automation part of the team and developers? Because nowadays, all the frameworks that we have on the market for building microservices, they come with quite powerful testing plugins or additions. Like, for example, Spring Boot has its own Spring Boot test extension that basically gives the developer possibility to implement quite nice and powerful integration tests. And one of the problems that I see nowadays is, how do we split the work between the test automation team and software engineers? Because again, now integration tests become part of software product and they are implemented in white box style, right? So that's probably one of the most difficult pieces, because in my experience, a lot of customers and projects, they already do some sort of integration testing with Spring Boot test, for example. And now, when we need to introduce real functional testing, the problem is, how do we split the work? So my suggestion in this case would be to have even sort of one single test plan for both of them, but some items from this test plan can be covered on component test level when you test your component in isolation from others, right? And some piece of the test plan can be covered by real integration tests. And when I say real integration tests, I mean real component that are running, and the tests that are implemented in black box style. So that's probably one of the interesting things I would mention.
Great, Andre. So yeah, so I think you've touched on something that's very, goes to the very crux of the idea of building in quality, shifting left, and those strategies that we have adopted in the past, right? So and then we'll get to some of those tooling and framework aspects as we go along. I've got some of those questions coming up. But Artem, you touched on some of the other facets of cloud native, which is the serverless technology. So that has got this other additional, because there isn't a physical thing anymore, right? I mean, there's no, it's just code that's run, it's like runtime behavior that you've got to validate somehow. And then you also have to leverage, and it inherently leverages some of the horizontal scaling in cloud that can build in other complexities like latency and things like that, cold start, So how as a tester would you advise our people in our profession as they go and approach cloud native testing? What should be the things that you'll be looking for in terms of skills, the areas to look for, identifying the right risks, and anything else that might come into a test vector that can fit into a test strategy?
It's a complicated thing, right? Because as Andre mentioned, right, it's very hard to draw the line when the developer's work finish and the tester work starts, right? And with microservices, right, how he was telling the story about like testing is in isolation is like fairly straightforward, right? Like if you're testing the isolated services. But the problem is not only in the isolated services. In order to implement single function, most likely you would need to touch more than one service, right? And that's problem. I believe Andre saw this problem when he was like digging through the Uber and stuff like that, right? Because like it's literally the same, right? When you need to implement a single functionality, you need to touch like 5 different services, which uses 7 different databases, right? Everything like writes the stuff to different places, and that's where it becomes nightmare, right? Because like eventually testing a single service in isolation is not enough, right? So you need to test 5, right? In order to test 5, you need to do somehow this CI-ish jobs, which will be able to deploy 5 and isolate from each from another, right? All of this contract testing and stuff like that, right? Because the microservice itself, it's like in, out, breakings very little, right? But when there are more of them, and more importantly, there are tons of different data sources that they are using, tons of different databases, that's when the thing starts going local, right? The serverless piece is even more interesting there, because like there is also in and out, right? But it's it's short-living. Yeah, not everything is short-living, but it's like the classical one is short-living, right? There are some that are running for a long time, right? But right, taking an event from somewhere, right? Like usually that's a queue, it's not like somewhere, right? Then processing, putting the outcome somewhere, done, right? And there could be a chain of that, right? In order to do processing, and in some cases you may see that that the approach there is very similar to this ETL pipelines, right? There are multiple jobs. Every job do it simple transformation, but in this case, it's also like using an interesting thing. Usually, in all of this cloud native work, the single event generates the records more than in one database, right? Which kind of even overcomplicates the testing, right? And the isolation and how to build that and how to test that, right? And when we say what skills do we want to have from the testing engineer in order to get it covered, right? most likely we want them to be a bit deeper in the analysis in the first place, right? Because they need to understand how it all works, right? In order to understand how to even plan your tests, right? You need to understand how it works, right? And in order to understand how it works, you need to be a bit of an architect, right? In order to at least like understand what those lines are meaning, right? You need to be a bit of a developer, right? In order to understand how that thing all triggered together, right? You need to be definitely good test designer, right? In order to transform it in some human readable format, right? And you definitely need to know automation because like somebody need to script it. And it may not be a single person, right? But it's kind of the combination of a skill may give you like a team who is capable of doing that. And that's all even not testing the specialized, let's call it specialized testing, right? Which is another layer of complexity for the testing of all of that cloud natives, because it like plays very different colors in very different situations.
Thank you, Artem. I think that is some
Venkat, I
Yes,
will just
Shrikant.
add on to what Artem
Sure.
mentioned. See, from my view, from a tester's perspective, from a skills perspective, in the current world, as Artem told, the guys needs to understand how the architecture works. Okay, so if you are entering a project where you speak about cloud, you need to get onto their wiki page or the KB page, understand how the flow of structure works, even in the high level view. That gives the business logic as well as the architectural logic. The second piece is the guys should learn about observability stacks. Say something what Adam mentioned about how you are going to trace a single set of data when it comes to you. How are you going to trace a single transaction, right? So each of the cloud platform provides a certain amount of observability stack. Say, for example, if you are taking Azure, where I have more interest in, we have Azure Maps, application maps, which will map the transaction to the functions, Azure Insights, which will help you to trace the data sets. So, and they have Azure monitors and analytics, which can be applied on top. So, which will help you to see through the transaction right from the beginning to the end, and you can also do a debugging and the triaging, which was mentioned earlier, right? So that is a skill which guys needs to get into. They should not shy away from looking into it. The third piece I would look for is a DevOps sort of a professional, where if you want to isolate a project or an environment to create, you should know some of the environment creation pieces. Now, everything comes on to IaaS, right? Infrastructure as a service. Either you know Terraform or Pulumi, or if you are working on GCP, AWS, or Azure. Azure has its own ARM templates. Now biceps have come. So you need to understand a bit of it. You don't need to be a great guy in there, but you need to do what is required to do, understand and do it. And most of these are declaratives. If you need to understand the declaratives, then you will be able to do. These are the skills which I would see that upcoming in the days, Venkat.
Indeed, yeah, skills. Yeah, go ahead, Andre.
And it just makes interesting to see how the companies cope with this problem, because basically, for example, the EPAM, right? So they introduced one more title, which is software engineering test, which is basically something in the middle of this triangle where the agency are test automation, software engineering, and DevOps part, right? So you need to have these skills to understand the architecture and the way the platform is deployed, which is basically DevOps, right? So you need to understand these frameworks to implement the stuff, which is more like software engineering. And finally, you have to be a tester, and you have to know how to implement test automation, which is automated testing, right? So in EPAM's case, that's special subset of the people who is capable to do this job. And I'm not really sure how other companies on the market solve this problem, because problem itself is quite interesting, right?
Indeed, I think all of you have touched on something that is very paramount in terms of the changing skill set as the landscape is changing, right? And that's where that's something we need to look into. And to Artem's point, also he was also mentioning that you've got to be a bit of an architect and a bit of a developer, and also know some of the technologies like the cloud specific capabilities and services, like Shrikant mentioned about the distributed tracing, and with your experience, Andre, about cost-cutting features going across the bounded contexts between the distributed databases that are individually maintained by the different microservices, right? So, how has been your journey, Andre, from your perspective as a tester? How has that evolved? Maybe you could spend a couple of minutes talking about how that evolved over time, and what other skills did you personally gain and really benefited that is helping our customers?
Well, that's a good question. And the right answer, it depends. It depends on the problem. It depends on some particular project. It depends on the technology, right? It depends on everything. But generally speaking, again, I would say that the thing is that if you have right people that have special knowledge and the ability to understand how the platform works, how the stuff is deployed, so you can come up with some particular solution for some particular problem. Like, for example, I know a lot of cases when this problem of component versus integration testing has been solved easily with framework that allow you to spawn real services with Docker, right? So basically, you can have your own piece of the real environment on your local machine and within your local environment, right? So sometimes it's not possible, and you have to you come up with some other techniques, and so on and so on. So that's why it depends.
Yeah, so indeed, so it depends on the type of solution. But to that point, you also talked. Artem also mentioned about the serverless architecture and the way. So from a serverless and not only serverless, but also from microservices perspective, some of these can be polyglot services, right? You can have different languages being implemented as long as and to Artem's point, the contract testing and the contracts are maintained, and you could validate at the contract level. That it can just scale up the type of and accelerate the type of development that typically happens with distributed systems. And it'll be very interesting, because as a tester, you've got to be looking at not just testing in isolation, but sometimes if you've got to go do pair programming and those kind of things, working with different developers in different domain-specific languages, right? So that adds another level of complexity, right?
And on the other hand, it's quite beneficial, because now when you test everything over an API, you do not care about the technology you use for testing, right? So you may know Python, you may know Java, you may know JavaScript, whatever it is. And you can easily use this technology to implement your tests, because basically almost all the tests are more like contract tests, right? So you just send the data, receive the response, and validate this response against some rules and so on and so on. The real problem is that when you have a lot of microservices and a lot of these small test projects, the big question is, how do you get the test execution results from it? How do you aggregate those results? How do you get valuable insights from those test results, right? And how do you finally interpret those results to understand the overall quality of your platform? Because in this case, again, when it was a monolith, right? So you can just run your huge subset of tests and say that if the tests are passed, if the test execution is green, then we're sort of done. Now you have 20 plus, 30 plus components, and some of them may be not completely done. Some of them may have some bugs, but those bugs can still allow you to go to production, for example. Because, for example, this piece of the functionality is not touched that frequently, or maybe it's not released yet, and and so on and so on. So the problem of understanding the test results having in mind that you have a lot of test executions and a lot of small test projects. That becomes a bigger problem. And the second one is the situations when you cannot completely test your platform until it is deployed in production, for example, which brings another topic, which is testing in production. Right, so I believe that moving into this cloud native world, moving all our applications to cloud and splitting them to small pieces, bring a lot of very interesting problems that we have not faced before.
Indeed, I know that's a very good segue that I want to bring in Artem, because Artem is an expert in some of the instrumentation around performance engineering and performance testing. And we know in the monolith world also, to some extent, we've benefited from chaos testing, chaos monkeys, and disrupted testing and things like that. With so many moving parts, and sometimes the challenge, as you mentioned, is the coordination of all these systems to orchestrate and work together with containerization that we'll get to in a moment. I want to bring in Artem and share his thoughts and experience and how performance engineering and that whole area of testing and validation has evolved as it grew from monolith on-prem to cloud-based systems and cloud-native systems in particular.
Yep. Like the general change which happened, right? But it's happened a lot before the actual cloud adoption, right? Once services was introduced, right, we were able to see which particular service are actually causing the problem down the line, right? Down the line of a request. And that sounds very good in theory, right? But in practice, when it comes to implementation of all of that transaction breakdown and stuff, sometimes we get into situation, right, when it's not hard to implement, right? It's rather a bit different. It's not a priority to implement it, right? To get the right data out of to get the right data in order to answer the right questions, because like all of this flexibility, all of this small components and stuff, speeding up the development, speeding up the delivery, speeding up the features, right? So like the developers and the business, mostly business, in my opinion, right? But that's again, no one knows who's there first, who's not, right? They're cracking the features, right? So that's the main thing. They're doing features, and less of a concern, like not always, again, right? But in most of the cases that I saw, they're less of a concern on the instrumentation of all around, right? So, like, and that shift, as you mentioned, right, when we're actually able to get to the root cause of to the root of a problem, right, to conduct the effective root cause analysis, it actually happened early, right? What clouds bring us, right, in the performance side of the things, is a bit an easy observability, right, because it provides like all of this many monitoring and log aggregation capabilities out of the box, right? That's one thing. Right? The other thing, right, what it brings us, less certainty on what you're actually getting in the results, because like the software deployed in the cloud, right, especially in the early days of all of this cloud stuff, right, it's all collocated, right, it's all fighting for resources on the same physical machine versus virtual machine, performance not always predictable, right? And that's where the scalability come into play, right? When you need to plan how to scale your software and stuff like that. Like all of this vertical and horizontal scalability was there before that, right? In smaller pieces, right? It's bigger, right? And bigger in terms of, now it's easier. So, and once it's easier, it's kind of widely started to being widely adopted, right? But that's not very new thing. It's just started to be wider, right, than it was before. That's probably from a performance perspective, that's the most I want to say, right? From the reliability perspective, it's a bit more interesting, right? Because like everything which you deploy in cloud, that's always fail, right? This or that way, today or tomorrow, right? But it always fail. Like, and your software need to be actually resilient enough, right? So it's need to be able to recover. It's need to be able to actually right, be partially operational, I would say, and stuff like that. And that introduced it, like, again, the interesting thing there, that's all of this reliability, recoverability, and stuff testing was introduced long before that, right? And it's kind of and the right teams that were doing that like in early days, right? But now, once the speed is increased, speed of delivery is increased, right? This start taking like I would call maybe a second breath or something, right? Because like again, that's the speed increasing, the components failing faster, right? And if they're failing faster, they need to recover, right? And that's but now also clouds takes a lot on their hands in order to make your software a bit more resilient, right? So like they will rerun your pods automatically, right? They will respond your lambdas automatically if they fail and stuff like that. So they're taking a pieces of that, right? But it's kind of, there is an important aspect in all of that is the data, right? So like they can relaunch the lambda or a pod, but if during the failure it actually corrupted some data that it was working, right? That's where the tricky moments coming from.
Indeed, Dr. I think you touched on two key things that I want to bring into this forum for your thoughts and insights. One of them is, of course, the data fidelity, as you mentioned, with the app resulting in a non-deterministic state that then needs to be recovered, right? And to Andre's point, it happens unless you deploy it in production. You really don't get the scale and the volume of requests and the infrastructure that's in place. And there's so many moving parts. And to add to the mix, you also see other complications from a developer tester perspective, with access to data, access to log to reconstruct the events and log aggregation, and then interpreting some of those things. So it opens up. It seems like a Pandora's box of issues that we really run into. And at this point, I want to bring in Srikanth and then ask him from his perspective. You mentioned about distributed tracing, and with transactions that are distributed with different databases confined within the bounded context of the microservices. There can be situations where we intentionally, by design for resilience, we implement fault tolerance. So maybe you can share some thoughts on how that can be simulated, tested, and then validated, perhaps, Srikanth.
So these are two questions in here, Venkat. I'll take the first one on the distributed tracing piece. Yes, it is, even though now the monitoring instrumentation has become a bit better with the data coming in. But still we have some challenges. The reason being, since it is distributed and we may not end up with using the same cloud or the same on-premise cloud or multi-cloud environments, there may not be a common logging and tracing system, right? Say if you have a data going into Google and to AWS and then come to Azure, there are stages. You may not have a single logging. Okay, so this is an area where it is evolving. CNCF Cloud Native Foundation, they also are investing on projects on these lines. One of them is open tracing, so these are standards which they're trying to bring in to have a one single view of observability. That's one. So the next the next question is on about the the failure testing and resiliency, how we can test, right? So now, since cloud, it's lots of moving parts. We spoke about it now. How are we going to test it? And when we speak about cloud testing resiliency, people tend to deviate towards Kubernetes. Kubernetes, yes, it is an orchestration layer. Kubernetes is one of them, right? There are multiple methods to test it. Even you can do kubectl, and then you can stop a pod, start a pod, delete some data, and then restart it. So those systems can be done. But again, there is a conscious effort from CNCF Foundation to bring in a standardization and better work here. So there are tools like Kiosk Toolkit, which is one of the good tools which we have, and we have Litmus, which is a CNCF Foundation's incubation project, which we can through which we can do a lot of kiosk failure scenarios, which we can orchestrate. And there are other commercial tools also. Say something like Gremlin is one of the SaaS-based provider who does kiosk testing, right? And Gremlin and even Kiosk IQ. They also provide such a SaaS services, and the importance is such right now. Even the vendors like cloud vendors like AWS has started their own failure as a service, which can be utilized by us. Azure has started Kiosk Studio. We can just use them as a SaaS service, and we can start testing the failure resiliency. And there's a heavy concentration of importance being provided in this area right now, because both the service which I mentioned from AWS and Azure has come in after 6 months time, and there's a tons of data which they have documented in their sites. So it's something which is happening great. And the importance beyond the technical point, right? We during the pandemic, we are still in the pandemic. We have been thrown out of anything, right? Now you can see companies like food delivery companies. Most of us agree, and I saw some statues being made in Russia for food delivery people, right? So it happened in India as well, where Swiggy is one of the vendors. They were just a food partner. They became a grocery partner overnight. How it is being able to do? They are utilizing AWS. They change their microservices to their functionality from a food delivery to a grocery delivery. So that's the beauty of the total system, right? And they're scaled, and just not them. All the other vendors also scaled. Even the telecompany, like what we use it right now, Teams, right? MS Teams. MS Teams was around 40 million users, were concurrent users been doing before the pandemic, and it went up to 110 million per day. So see the change, and they were able to scale up. It's all because of cloud. So this, again, if it fails, how it feels. Last year, MS Teams failed in February, and we are all out of bound in APAC region. So, so the resiliency is very important, and so is the changes, right? So that's my thing, Venkat.
Yeah, indeed. So it opens up a lot of opportunities, right? While you trade off there's a trade-off between operational complexity versus development complexity, which Artem touched on earlier, with the adoption of cloud native, right? And at the same time, and Andrew rightly pointed out, and you also mentioned about some key tooling that's kind of fitting into that opportunity space that's coming in to address some of these challenges emerging out of these emergent architectures. So and with the scale of services, and you talked about the huge volume that comes in, very quickly you get into this horizontal scaling with so many different services. And I also talked about how one service request, is kind of chained across so many different contexts. And then there's this reconstruction of the eventual response that needs to be sent out. You quickly get into a spaghetti of sorts, and it's not anywhere near the complexity we have observed with monoliths. So, there are these meshes, there's like Istio and things like that kind of help you orchestrate some of those, or deploy and help you configure that quickly and deploy different versions even of microservices. And so from a continuous testing perspective, with all these different tools that are available, what are some of the challenges or opportunities that we see as testers that we can integrate with different tools into the automation pipeline? Andre, maybe your experience you can share.
Yeah, like first of all, probably I will have some small addition to the list of chaos tools, because recently we had some sort of evaluation of those, and we realized that sometimes the tools like Litmus seem to be too complex to start with. right? And people become a bit afraid of the complexity of those tools. So the one that is called Chaos Mesh is probably a good replacement for those who are afraid of the complexity, because this one is also created for Kubernetes, but it is super simple. And even myself, who do not really have a lot of experience in chaos testing, can start working with it in a couple of hours. So just to write down for those who is listening, probably this is a good start. Now, getting back to your original question about the technology and opportunities and challenges. First of all, I would say that now it's sort of the time of schema-based approach sort of revival. Because remember some time ago we had SOAP, which is basically the schema-based web services, right? Then the market was full of RESTful services, and now with this complexity of the 100 services, we understand that it is quite difficult to work with them without having some sort of schema, and that's probably sort of new life for the schema-based approaches again, or protocols. And I would highlight some sort of gRPC, which basically helps you to avoid additional contract testing because your contract is already defined. And in the real world and on real projects, that really helps you to test that kind of services, because basically, again, you do not need to test schema itself. The schema is already there. Now, usually when it comes to the complexity and testing of those hundreds of microservices, the very important thing is to be very smart at the start and build some sort of platform or core framework, or no matter how you call it, but the core of your testing platform that will allow you to build new tests easily and in very fast fashion, let's say. So if you are good at this stage and your platform or testing framework is good enough, then you will be very successful in writing and covering new tests, new services with automated tests. And again, that brings new kind of one more question regarding the technology that we're going to use. So nowadays, for example, in Java world, we have REST Assured, which is just a framework for testing REST services, right? But in reality, you need to build core of your framework based on this REST Assured. You need to fulfill it and empower it with the additional functionality that you might need in terms of reporting, in terms of the distributed tracing, and so on and so on. And when you have this core defined, you basically can go and easily implement tests for lots of services. And as a result, you may have a problem when you are not that smart at the start. And when your platform or testing framework is not that good, you probably will live with this and will feel a pain of this for quite a long period of time. So again, I believe that apart from QA side, building the testing frameworks, continuous integration part has a lot of sense here, because again, your jobs or your skeleton jobs, that they also needs to be sort of scalable, right? Because you will have a lot of testing jobs, or maybe you will have not that many of them, but still quite parameterized ones. So all this stuff that you built at the very start of the project needs to be scalable itself. And scalable not in terms of the instances that you're gonna start, but scalable in terms of the complexity. So it can allow you to plug in and plug out the functionality. So I believe that that's probably the most challenging part in terms of the test automation when you start working with complex distributed systems.
Indeed, Andre. So I think you touched on some of the key things that come into play when you look at the scaling out of these services and the challenges associated with it. So that brings in another topic, and I think Artem, you touched on it briefly earlier about the type of patterns that we see as cloud-native microservices-oriented architectures come through, which is the message broker middleware that kind of is the event-driven approach to implementing some of the microservices. And that adds another layer of complexity to these, not only testing the services in isolation, but then with the asynchronous nature of messaging and communicating between the, what shall I say, smart systems, but dumb pipes. So, that adds a lot of, another layer of dimension of complexity. So, from our experience, right, as you build these tools and accelerators and solutions, how does that mix come into play? And then from your experience, see customers either using it or adopting it or having a point of view on that front?
But that's an interesting story, because nothing really changed there, right? For a while, right? So like similar to API, right? You have let's kind of circle back on some days and days before, right? You have a file with the data, with the prices for your with the new set of prices for your e-commerce, right? Like what you was doing, you was uploading those prices to your shop and they were somehow applied, right? Now you have many shops, right? They're distributed, right? You don't want to go and upload them one by one. So you're kind of having the same type of a file, you're dropping it somewhere on the S3, for example, right? Or any other object storage. It generates event, right? For the tester, how it looks for tester at the end of the day. If we know the data in that file, right? And how this data need to change the price on the front end, right? That's enough. Dropping the file, waiting for 15 minutes, going checking the shops, right? Definitely there should be some triggers and stuff, right? Maybe some jobs are running like on the schedule, but there are always a plug how you can execute it, right? So like that's as simple as that, right? So it's complicated at the end of the day. There are events, there are pipes, there are data ingestion mechanism, there are like some conflicts resolution and stuff like that, right? But at the end of the day, for QA, right, dropping a file, waiting 15 minutes, going checking that this thing changed, done deal, right? Then when the thing is not changed, right, then we're falling back to what Shrikant is mentioning, right? We're going there, going into logs, seeing all of this distributed tracing, which of the steps down the way throw us an exception, and then like creating an issue report, right? So like some of that, like definitely for the dev testing, right, is another piece, because they will test every component independently and stuff like that. Spin up the local environments, spin up then environment and cloud, right, which introduce yet another risk, the stale resources in the cloud that somebody need to clean up after that, right? Maybe they, maybe not, right? Because that's something that new to the world, right? That you are responsible for the resources you are actually leaving, right? And but from a testing perspective, right, from a functional testing perspective, it's as simple as that. From the performance testing perspective, it's a bit more complicated, but also not as much, right? Because like there are simple throwing, waiting, checking, measuring, right? They are complicated, a bit more complicated when throwing and then checking on every step of the way when in the logs or any other aggregation system, the stamp will appear that the event is actually processed, right? How many events, the throughput, all of that configuration. But at the end of the day, right, we are getting to that situation without like much of a harm for standard processes.
Yeah, but sometimes it's not that easy even from QA perspective, right? Because in real life, no one of those steps are implemented at the same time. And usually when you have this chain or pipeline of the events and different teams are working on those pieces or microservices, you have two microservices in the middle which are not done and break all your end-to-end tests or functional integration tests. And that brings another process-based problem. How do we synchronize the work across the teams?
It's basically we're getting back to to the release strategy, right? And how we're deploying and what the integrated environment we actually use for testing and stuff like that. And how that, because like the situation that you describe 100% valid, right? And once we observe that this service, which Roverlock not implemented forever, right, is not done, right? The first question we need to ask ourselves how we get to an integrated environment.
Exactly.
So, Andres and Artem, you touched upon the real project issues, right? Right now. So, one thing which I seen in one of the projects, recent projects, is see they were. Two things. One on the unit test itself, right? Andre was mentioning about the responsibility split in the early of the conversation. It was very interesting because I faced this. The response on the unit testing side, how we can isolate and do. See, there are tools which are available right now in most of the cloud vendors, say Azure Functions, right, like a Lambda in. So there you can test that within your isolation. You don't need to even go to cloud. You can test it. You can create a trigger. Triggers can be anything. It can be a webhook. It can be a HTTP trigger or whatever. It will trigger the Azure Functions, and then you can test it. It's all can be done in within your laptop. It doesn't need to go to connect to cloud. So you don't need to do multiple deployments and other stuff, right? And you can bring in that more things, quality in there. And the same thing happens with AWS. We have something called SAM, Serverless Application Model, which we can do the same. So there can be more impact on the unit testing, and they can bring in those changes. On that side. The second piece, you mentioned about features not being tested in all. One feature getting tested and it's not complete. So this is an inherited problem when we work in an agile distributed team. We don't have an answer to that. Again, it goes to the point on the how are we going to do in the deployment and the release strategy, and how are we doing the testing in the production to validate it. That's the point where we come about canary type deployment, A and B deployment, blue and green deployment strategies, which will say what I will flag off the feature flags and stuff we will implement to make sure that it doesn't break. But it's all assumption that we do our best, but the velocity at which things goes, we don't know what will happen. So these things along with the quality gates is what best we are trying to do to ensure things doesn't go bad.
Yeah, what I'm saying is that all this zoo works perfectly fine when all the components of this picture are in place. Like, for example, let me give you some funny example. So some time ago, I was working on the project, and we had a lot of processes established. We had component tests, integration tests. We agreed on the way we're going to release this stuff, and everything was perfect. Until one moment when one guy just pushed update to the schema in the middle of protofile. So if you worked with protofiles, you know that if you put something in the middle, you basically change the order. And basically it means that all the schema breaks. And this small change, someone just forgot to restrict the pushes to this repository. And this repository was a registry of all schemas. So basically, this one small change in one line break everything, literally everything, because two of like 5 or 6 components were not operable, and they break all the chain of the events coming from one side of the platform to another one. And yeah, the only piece that helped us to trace it quite fast was distributed tracing. Simply because it was in place. If we didn't have it, we would spend probably a couple of days to understand what's going on with the platform. So what I'm saying is that only when you have well-defined processes and well-defined release procedures, and when well-defined, even versioning, only after this, all this, good and nice theory start working. Otherwise, it just does not.
Yes, thanks, Andre. So that seems to be summarizing a lot of the things that we've been talking about. We've got 2 minutes to wrap up our exciting discussion. I'm sure there's a lot more to it than we can try to fit in an hour. It's been an exciting conversation. So before we do, concluding thoughts, if you want to summarize your views, I got some ideas that I think I could start off with. Basically, so it seems to me that the migration to a cloud native strategy is not for the faint-hearted. It's got to be clearly thought through. It's got to be a good strategy, and it's because it's got an implication on the team structure. Typically Conway's law, we know how systems are aligned to your way of working, structuring the teams, and the way the moving parts work. So with that, I want to take the opportunity to thank all of you panelists for taking your time. It's been a super exciting conversation for me. I hope the audience also learned quite a bit from it. 30 seconds for any parting thoughts. Anyone?
I think we've run a pretty intense discussion, right? That's just about time to say thank you. Thank you for your time. Right? And
indeed, Artem, thank you so much. Thank you, Andrew.
For organizing, Artem and Van Rijk same time, but we didn't have such a talk. Try to conduct more. We'll have share our time.
Indeed. Thanks.